Alright, well, I guess we will begin. My name is Joel Elliott. I'm the owner of Elliott Manufacturing. I've been in business since late 2004, early 2005. At that point, what I did was I was working for a company that erected steel buildings. I was a project manager and a cost estimator. We put up pre-engineered steel buildings, a lot of agricultural and commercial, which my business, Elliott Manufacturing, still does. And then we had a need for using steel studs quite a bit, so I ended up purchasing a steel stud roll forming machine. It was a giant piece of junk and did not work worth a darn. So I just kind of pushed it into the corner and didn't really use it. And at that point, the methane boom here in Sheridan, Wyoming got going pretty hard, so we started doing a lot of welded panels. We built the cattle panels that went around the wells. And we did, I can't even imagine how many of those we ended up doing, but we did that for quite a while. And then I decided that I was going to get back into steel studs, so I sold the machine that I had, and I ended up working with a company, and we purchased a new machine. This new machine, what it does is we have a complete software suite that goes along with it that does all of our design, does all our truss engineering, and also most of the engineering for the walls, which there really isn't a lot that goes into engineering the walls. It's the trusses that take up the bulk of the engineering. And then that software package, we do the design on it, and then we ship it off to the machine. The machine is basically, for lack of a better term, it's a CNC roll former. We group individual walls into panels, so we'll have a job, let's just call it, Barker, and it's broken into 7 wall panels. There's wall panel 101, 102, 103, and 104. All that information from wall panel 101 goes through the machine. The machine makes all the parts that we need to assemble that wall panel and put it together, and then also produces a drawing as well. The computer produces a drawing. We might as well go ahead and go on down to take a tour of the rest of the shop and show you what we got going on. Show you some wall panels and how some of the stuff goes together. Again, I apologize for the video being a little bit shaky. I'm doing this all freehand. All right, walk down the. Yeah, we'll stop here on the landing. Take a little view of the shop. I got one of my work trucks in here, my forklift, and this is my shop. Over there on the wall is the steel stud machine that manufactures the wall panels and the trusses. We got an old iron worker down there, a punch press, and just some various odds and ends. Here in the shop, got my office up here. Underneath, we got some machines that we use to help build some different tooling and dies that we need from time to time. Also, tools and basic hand tools and benches and whatnot to maintain some of our equipment. Come along here. These are some of the wall panels for a job that we're currently rolling. These are real lightweight. These are a 3.5 inch 20 gauge material. This is the material that you would be receiving for your buildings. We've got a single piece horizontal material in the middle. We got our studs right here. We got another stud and another stud. You can see the utility holes. Those are utility holes that are 1.5 inches by 4 inches, and we can locate those anywhere we want and any number of them that we want. I've got one here, I've got one in the blocking, and then one below the block. You can see right down there. Kind of keep doing our little tour here. We got a little shear, little Pexto 4-foot shear. Got an iron worker right there that's in need of a new hydraulic pump. That's on its way. Got my forklift here. We have the capability to be able to handle anything up to 8,000 pounds. Whether it be a coil of steel or a finished job. This is how some of the material comes. this is our steel stud coils right here. A couple of our steel stud coils. They come in a coil form, just basically a big roll of steel toilet paper essentially, and that goes on our machine, and that's what gets formed into a steel stud. These particular ones here are only about 900 pounds. We can handle up to 6,000 pound individual coils. These ones here are a little bit heavier. I think they're around 2,000 pounds each. A little different material. Move along here. Over here we have our 12-foot brake. We have a 5-foot brake there. That red one is a 5-foot brake. This one's a 12-footer. And then we've got our slitter table that we use to slit sheet metal down to make trims, headers, things like that. This is a machine. This one makes our steel sheeting. We make our own line of sheeting that goes on the outside of our buildings. You can see how it's laid out. We've got a strip in there right now just to keep the rollers from rattling around. We've got our decoiler here. This is our decoiler, and this is a coil that's about gone. This is a 20 gauge. This is a material. This starts out 7 3/4 of an inch wide, and by the time it's done, it makes a 3.5 inch stud. This is a 20 gauge material, and then we've got another short coil right next to it. So when this one runs out, we will weld this one to this one and keep going through the machine. This here is the steel stud machine. It is a CNC type of machine that moves forward, makes steel studs, and does a whole bunch of punching. This particular punch station right here is called the lip notch. That's what allows us to notch out the return lips on a steel stud so that we can place another steel stud inside of it, and that's what allows us to use steel stud in place of track, steel stud track. This is the web notch. This, in conjunction with this, is what allows us to pass a steel stud through pass a vertical steel stud through a horizontal steel stud. You have to have the web notch and the lip notch in order to do that. The web notch takes a chunk out of the center, and then the lip notch takes a chunk out of the edge so that you can pass a stud through. This is the utility hole. This is the one that makes all the holes that are 1.5 inches wide by 4 inches tall. That's what makes the hole for electrical to go through. And as it goes along, it just successively starts making the panel a little bit bigger. This is the utility hole. When you do the web notch and the lip notch, it's all done in the flat state before the part is rolled. So if instead of this utility hole here, if there was a web notch, it would be a hole running this way, and the lip notches would be in these are the little return lips. And as it comes along, it just progressively starts turning more and more into a stud. And it moves along, and right about here it is in its finished state. This is as formed as it can possibly get. We got some more punching stations here. This is a station that allows us to make our trusses. What this punch does is it punches a locating hole. So everywhere a web crosses a top or a bottom cord, it punches a hole in it. And what you do is you line those holes up, you run a screw through them, and then you have a corresponding drawing that goes along with the truss, and that is what tells you how many additional screws need to go in that particular area. This station right here is the dimpler. This station right here is the swedger, and this is our print head, and then of course our shear. And as it comes out, it has this is a finished stud. What this is this is the swedge right here, and this is the dimple. So whenever you put a piece of stud into a piece of track, everything has a dimple and a punch, just like this. Everything has a corresponding dimple and punch, and that is how you know when those pop together. That's how you know that you're in the right location. What this swedge here does is it gathers up this end of the stud. It gathers it up. It makes it just a little bit smaller so that it will fit inside of another stud. I've got hold on a second here. I've got a piece right here. So if this were a wall stud and this were a piece of track, what you would have is this, you'd have a lip notch right here, so that this piece would fit inside of that, and you would also have a corresponding dimple right here, so that when this piece popped in, that dimple would pop in, and that's where you place a screw. I'm going to get down here and hopefully we can see it. Yeah, you can see it pretty good right there. This is what the print head prints on the parts. This is the nomenclature that tells us what everything is. Right here, Concord. This particular job is for a company that's called Concord. S15 is a level, so that means this means this is level 1. If it was say S10, it would be level 2. S5 would be level 3. So S15 is level 1. This 5 stands for the wall panel, so that means this is wall panel 5, and this I means this is part I. So we have Concord is the company we're doing the job for, or the name of the job. S15 is a level, so this is a level 1. The 5 means this is for wall panel 5, and the I means this is part I for wall panel 5. Really, the 5 and the I are the only real important things that we need to know. This 350 S162, that means 350 means 3.5 inch. The S stands for stud, and the 162 stands for inch and 5/8. So that means it's a 3.5 inch wide by inch and 5/8 tall stud. 43 mils is the thickness of the metal. 33 KSI is the yield strength of the steel, and G90 is the galvanized coating. 43 stands for 18 gauge. 33 is the yield strength, so it's 33 kips per square inch, and G90 is the galvanized coating, which means this has a galvanized coating that is equivalent to a G90 or better. And that, in a nutshell, is how everything works. And that's when you have that 5 and that I on there in the print string, that's what tells us where everything goes. That's how we know where every part fits. Grab a drawing over here. This is the drawing for the wall panel that we're about to go look at. This is the drawing. It's a little difficult to see. There, you can see it right there. You can see how we have M and C and an H and an F. Those are just the same as the I that was on the part that was sticking out of the machine. In fact, there's an I right there. But this is different because this is wall 1. This isn't wall 5. It's wall 1 for Concord, and that is part I. So this part would not be the same as the part that's sticking out of the machine that has an I on it, but it is for wall 5. The one that's sticking out of the machine is for wall 5. So you get a decent look at this. This is a gable end wall panel, and it has an opening in it for a double 4-foot walk door. So it would be technically be an 8068. So that means it's 8 foot wide and it's 6 foot 8 inches tall. Just like a standard walk door, only it's 8 feet wide, and it's a double swinger. We have a single piece of horizontal blocking. Of course, we have our bottom track, our top track, and all of our studs. And this drawing shows how the wall panel gets put together. That in conjunction with the markings on the studs. You can see how we have our utility holes. There's one in the bottom. There's our bottom track. There's a utility hole in the bottom. There's our centerpiece of horizontal blocking, and then we have another utility hole in the top, and then we have our top track. Again, this we can put as many of these in here as we want, in as many locations up and down this wall as we want. This is a 24-inch on-center spacing for our vertical studs. We can do that in a 12-inch, a 16-inch, pretty much just about any scenario. This is a little better example of how I was trying to explain over there on the machine, how you have a swedge and then you have a lip notch. That's how this piece, this stud, fits inside of another stud. That's how everything goes together. And then you can see the dimple where the screw hole is, and that's how you place the screw. That's how we know that this part, that's how we know where this part fits with this part. You slide this part in, and when it lines up, when those two holes line up, then you put a screw through them, and the screw head sits flush with the bottom track. Same thing here. This is our horizontal piece of blocking, which means the stud has to pass all the way through it. So we have a lip notch, then we have our dimple, so we know where everything goes, and then we have our web notch right here. That's where we know that's where everything passes through. Now when you're putting vertical sheeting on, you have to screw it to your bottom track, your center piece, or however many pieces of your horizontal blocking you have on there, and then also your top piece. If you're putting siding on horizontally, then you screw it to the studs, and you don't worry about screwing it to these. Now, on the buildings that we'll be making for the treaters, what we will have, so that we can locate this. This is a gable end wall. I don't have a side wall anywhere that I can take a look at that's easy to get to that hasn't been spray foam insulated. So it's going to be a little bit. I'm going to try to explain as best I can how the truss to wall connection works with these treater buildings. What you will have on a sidewall, you will have a row of studs, just the same as this. Everything will be identical. However, instead of having a top track here with no hole right here, like you have with the blocking, you'll have a piece of blocking up here. That piece of blocking will be right here in place of this. The stud will carry through another probably about 7 inches. I think that's about what it is, like 6.5 inches. The stud will carry through here another 7.5 inches or so, 6.5 inches, and it will have a single hole in it right here. That single hole will line up with a hole on the truss that's coming in. That truss will come down, the top cord and the bottom cord will come together, and the top cord will have a hole in it, and that is how you locate it. You line the hole in the top cord up with the hole in this stud that's poking through. You put a single screw in there, and then you put 4 more screws in the area around it, and that's how you line your trusses up with your wall. Then you come across your trusses and you place the hat track on top of them on a 2-foot interval spacing, and then you attach your sheeting. That's literally how simple it works. So everywhere there's a stud, that stud will pass through. Now on your gable ends will look exactly like this. They will look exactly the same as the one that we're looking at right now. This one here has an L header on it. We've got a double king stud. Since it is a walk door and it's not a garage door, we don't really have to be too concerned with how strong this is. It just has to be strong enough to hold the jam. So we have a double king stud here since it is such a wide door. We have our upper sill, we have our top track, and we have an L header. The L header comes across, and then it's 1.5 inches down. I believe this one is like 8 or 9 inches, which is what our engineering program told us we needed to be in order to carry this load. Any door openings that are very wide, I try to only use L headers on just simple walk door openings of 4 foot or 3 foot. In this particular case, since it is a gable end wall and it's non-load bearing, we just went ahead and put an L header in there. Normally there'd be a pocket framed in right here, and we'd have a stud laid in here horizontally on this side and then one on the other side, and it would be welded to this sill piece and then also welded to another piece that was running horizontally, and that's how we would be able to span large openings. Now this opening is for an 8-foot wide by 6-foot 8-inch tall door. It is a double swinging door. In fact, it's sitting right there in that crate. Now when we make a panelized system like this for field assembly, your actual rough opening is not from here up to there. Your rough opening goes from there down to here. This piece is meant to be cut out on site and then the door put in. Now with the treater buildings, there's a couple of ways we can do this. We can make our rough opening big enough to leave this piece in, so our rough opening, instead of starting right here, would start right here. Or we can build a temporary piece that just screws into the throat of my stud right here and maintains your rough opening from the bottom to the top. It's entirely up to you. If you want to retain this piece, that's information we will need to know so that I can start your rough opening right here rather than right here. the computer design system automatically starts all rough openings at the bottom unless I tell it otherwise, because it assumes that this piece will get cut out as soon as this wall panel gets stood up. I hope that makes sense, but that's how everything fits together. And again, we've got our horizontal piece of blocking there. Again, I can put as many of these in as I want, however many we need. And again, this is a gable end wall. When I do all my designs, my side walls, they fly past the gable end wall. So your side wall, if your side wall was buttoned into this piece, your side wall would be flush to right here, flush to the outside, and then would fly past. So this is actually set for a 24-foot wide building. So this is 3.5 inches shorter than it needs to be. So normally it would be another 3.5 inches wider. And so you'd flush up the end of your gable end wall with the outside of this wall. And that is how it works.